The James Webb Space Telescope is causing quite a stir, forcing us to reconsider the very foundations of our understanding. Suddenly, it dawns on us that we may need to rewrite the entire cosmic narrative found in textbooks. Welcome to Spaceverse, your portal to the mysteries of the cosmos. Join us on an incredible journey through the universe where we'll unravel the secrets of black holes, venture to distant planets, and witness the latest in space exploration. Subscribe to Spaceverse today, and let's dive into the cosmos together. Let's start. In the far reaches of our solar system lies the dwarf planet Pluto, which is considered a celestial outlier. This region, known as the Kuiper Belt, is home to a multitude of minor icy planets and asteroids. It is once hailed as the 9th planet in our solar family. Pluto was affectionately named after the Roman god of the underworld. However, in 2006, prevailing scientific theories dealt a blow to its planetary status. As per the current understanding, the solar system comprises numerous asteroids, a select few dwarf planets, and just 8 bona fide planets. Over the course of several centuries, our comprehension of the cosmos has expanded significantly, unveiling the inner workings, composition, and potential habitability of these celestial bodies. But what if there's more to unravel within our very own galaxy? What enigmas has the James Webb Space Telescope finally unraveled concerning Pluto? Could there be life lurking in its depths, whether familiar or exotic, and perhaps even an enigmatic subterranean ocean? Prepare to embark on a thrilling journey as we delve into the captivating mystery unveiled by the James Webb Space Telescope, one that lay concealed all along. For 76 years, Pluto held a special place in our hearts as the 9th planet. Its diminutive size and charming idiosyncrasies endeared it to both kids and adults alike. You could relate to its status as a cosmic misfit. Pluto's unique character evoked a strong emotional connection, and its reclassification as a minor planet 15 years ago stirred public outcry. This reaction shouldn't come as a surprise. The International Astronomical Union, or IAU, revised its definition of a planet, and Pluto found itself excluded from the celestial roster. According to the new criteria, a celestial body must meet 3 conditions to be considered a planet. It must orbit the Sun, have sufficient mass to adopt a spherical or near-spherical shape due to gravity, and clear its orbital path of debris. Alas, Pluto fell short on the 3rd criterion, leading to its reclassification as a dwarf planet. The concept of planet has been defined in broad and evolving terms throughout human history. Back in the 1600s, when Galileo turned his telescope toward Jupiter, the prevailing notion was that any substantial celestial body orbiting in the heavens could be considered a planet, even including moons. The rocky objects we now categorize as asteroids discovered by astronomers in the 1800s were also initially regarded as planets. Pluto, too, embarked on its journey as a bona fide planet. Its debut came in January 1930 courtesy of the amateur astronomer Clyde Tombaugh. Armed with a telescope and utilizing photographs, Tombaugh, then a staffer at the Lowell Observatory in Flagstaff, Arizona, made the groundbreaking discovery. He promptly reported his triumph to the observatory's director, exclaiming, "I have found your planet X." Tombaugh was referencing the hypothetical 9th planet postulated to exist beyond Neptune's orbit. Yet the cosmic narrative took an unexpected twist when it became evident that Pluto was not alone in the cosmic expanse. In 1992, astronomers unearthed an object merely a fraction of Pluto's size lurking beyond its orbital path. Since then, the discovery of almost 2,000 frozen entities within the Kuiper Belt, the frigid periphery of our solar system, has added to the intrigue. The potential for even more revelations looms large. The existence of numerous neighbors surrounding Pluto raised perplexing questions. What commonalities did these unfamiliar celestial bodies share with Earth? What set them apart in the celestial chorus? Suddenly, astronomers found themselves grappling with the enigmatic definition of a planet. Enter Professor Mike Brown, a planetary scientist at Caltech in Pasadena who left an indelible mark on this celestial conundrum. In 2005, he unveiled the first Kuiper Belt object, a celestial entity seemingly dwarfing Pluto at the time. In a nod to the television show Xena, Warrior Princess, this icy remnant was christened Xena. This frozen relic of a bygone era harks back to the early days of our solar system, when the Sun and planets were still in their celestial infancy. Mike Brown's audacious proposal threw down the cosmic gauntlet. If Xena deserved the title of the 10th planet, then surely Pluto, as the 9th, must uphold its planetary standing. However, should Xena fail to meet the planetary criteria, then Pluto's claim to the title would be equally challenged. The year 2006 marked a dramatic turning point in the ongoing debate over the celestial statuses of Pluto and Xena. Tensions simmered and ultimately boiled over, leading to a climactic showdown at a conference of the International Astronomical Union held in the historic city of Prague. The august gathering of celestial minds delved deep into the intricacies of planetary definitions, and after exhaustive deliberations, a new and revised planetary concept emerged. The fate of Pluto and Xena hung in the balance, and the verdict was delivered on the final day of the August conference. Both Pluto and Xena were stripped of their planetary titles, only to be adorned with the somewhat less glamorous designation of dwarf planets. In the case of Xena, a celestial figure whose name evoked the Greek goddess of strife, the cosmic rebranding was nothing short of poetic. The new nomenclature seemed fitting, given Xena's pivotal role in revolutionizing our understanding of the solar system's dynamics. Indeed, the name change resonated with the cosmic discord it introduced. So profound was the impact of these cosmic reclassifications that Professor Mike Brown, whose groundbreaking work had played a significant role in dethroning Pluto as a planet, earned himself the tongue-in-cheek moniker of "at the rate Pluto killer" on Twitter. Following the redefinition of Pluto's planetary status by the International Astronomical Union, or IAU, the scientific community experienced a division in how they perceived this change. While some embraced the new cosmic order, others resisted, fueled by a mix of reluctance and skepticism. To shed light on the ever-evolving nature of the term planet, a group of scholars led by Metzger embarked on a literary journey through scientific history, discovering examples like Ceres. Ceres, initially regarded as a planet when discovered in 1801 within the asteroid belt, faced a similar fate as Pluto, losing its planetary status as more celestial neighbors were unveiled. This narrative underscored the complex and evolving definition of the term planet. But Metzger's group challenged this conventional wisdom with a bold assertion. The accepted story was not the whole truth. They contended that, remarkably, even into the 20th century, Ceres and other asteroids continued to enjoy recognition as planets, albeit minor ones. In a 1951 report from Science Newsletter, thousands of planets encircling the Sun were acknowledged, albeit with a caveat that the vast majority were relatively diminutive, ranging in size from that of a city block to the expanse of the state of Pennsylvania. It wasn't until the 1960s, with the advent of space exploration, that the term minor planets took on a derogatory connotation. During this era, scientists peered at these celestial bodies from spacecraft for the first time, revealing the undeniable truth. The largest asteroids did indeed bear a planet-like appearance, while their smaller brethren displayed irregular, lumpish characteristics. This pivotal revelation dispelled the notion that smaller asteroids were merely shrunk conversions of their spherical counterparts, ushering in a new era of celestial categorization. The decision to reclassify asteroids, surprisingly, was not influenced by their tendency to remain in orbit. Moons, on the other hand, had an interesting history of being referred to as planets or secondary planets by scientists until the 1920s. The persistence of this practice, despite mounting scientific evidence against it, was largely due to non-scientific sources, especially astrological almanacs, which simplified horoscopes by keeping the number of planets concise. However, with the advent of new space exploration knowledge, some of the larger, spherical moons were gradually reinstated as planets, starting in scholarly publications in the 1960s. This highlights the ever-evolving nature of the term planet, as defined by the International Astronomical Union, which serves to prevent an overwhelming proliferation of planets, prompting us to consider the challenges of a universe with countless planets, and what motifs we might decorate our lunch bags with in such a scenario. In contrast, there's a concern voiced by Metzger, one that urges us to consider the potential pitfalls of focusing solely on the 8 familiar planets. This perspective suggests that such a limited celestial ensemble might inadvertently discourage the exploration of the cosmos, dimming our thirst for cosmic knowledge. In the end, it raises a tantalizing question. Could the definition of a planet be, at its core, subjective? In 2015, the cosmic stage saw a breathtaking performance when NASA's New Horizons probe swept past Pluto. The once underestimated dwarf planet revealed itself as a thriving hub of activity, surprising all who beheld it. Nitrogen cliffs reminiscent of Norway's rugged shorelines and methane ice spires soaring to heights rivaling skyscrapers now adorn its landscape. Meanwhile, Earth bears its own celestial scars, with rifts plunging deeper than the Grand Canyon and frigid volcanoes towering even higher than the Himalayas. The probe's cameras captured a heart-shaped feature etched on Pluto's distant face, a sight that left millions of Earth-bound spectators awestruck. 8 years have passed since the remarkable first encounter with Pluto, and scientists remain captivated by this distant celestial body. New Horizons, traveling at a breathtaking speed of 32,300 miles per hour during its closest approach, could capture detailed images of only one side of Pluto, with the other side hidden in darkness. Recent scientific investigations are finally unveiling this concealed aspect of Pluto known as the far side or the dark side. These photographs, despite their limited resolutions, provide a remarkably detailed view of Pluto's landscape, offering precision up to a mile, far surpassing the capabilities of the Hubble Space Telescope. This fresh perspective is shedding light on long-standing cosmic mysteries, including the intriguing question of whether an underground ocean exists beneath Pluto's icy surface and the processes that shape its unique terrain. The enchanting statistics embedded within these images even whisper tantalizing hints of Pluto's potential to host life in the midst of its frigid domain. Yet, the celestial portraits unfurl a cryptic narrative of their own. For example, the striking ice structures that resemble towering skyscrapers, a recent discovery on Pluto's distant countenance, now astoundingly seem to be in an orbital ballet around the dwarf planet. This newfound revelation bequeaths to us a conundrum. What intriguing Genesis story lies behind these enigmatic formations, now etching their own legend into Pluto's storied history? Enter Richard Binzel, a planetary expert from the Massachusetts Institute of Technology in Cambridge, who enthusiastically declares Pluto to be an ever-giving celestial marvel, casting our minds back to 1996 when we marveled at pixelated surface details courtesy of the Hubble Space Telescope. Even the slightest glimpse ignited our fascination. Those early snapshots, while somewhat unclear, revealed a planet-like sphere with global contrast surpassing that of Earth, establishing Pluto as a remarkable cosmic gem. In July 2015, New Horizons embarked on a memorable journey presenting us with a cosmic symbol of love, a heart-shaped feature situated just north of the near-side's equator. This radiant emblem of cosmic affection unequivocally confirmed Pluto as a vibrant and dynamic world. At its heart lay the captivating Sputnik Planitia, a frigid basin pulsating with the energy of colossal glaciers. As ice sublimated into the atmosphere, it rose into the sky with the sun's gentle touch, falling gracefully to the ground under the starry night, hinting at the possibility that Pluto's heartbeat might have played a role in its cosmic dance to its current celestial position. In the Cosmic Symphony, Francis Nemo, a planetary virtuoso from the University of California, Santa Cruz, orchestrated a tale of discovery alongside fellow cosmic composers. Their journey focused on the mysterious Sputnik Planitia as the initial images of Pluto's near side reached Earth. A peculiar note sounded in this cosmic overture, as this frozen basin aligned almost perfectly with Pluto's largest moon, Charon. Despite a mere 5% chance of celestial collision, simulations unveiled an alternative story. An enigmatic subterranean sea began its ascent as the icy rift formed, drawing nitrogen gas from Pluto's atmosphere and preserving it in the frozen crater. The celestial dance of elements had choreographed Pluto's current cosmic alignment through the gradual accumulation of water and ice. The discovery of a hidden ocean beneath Pluto's surface gained new life with images of the far side, shedding light on long-standing cosmic speculation. Chaotic terrain, a patchwork of perplexing hills, cracks, and plains provided substantial clues. Scientists hypothesized that seismic waves triggered by celestial collisions on Mars, Mercury, and Jupiter's moon Europa converged on Pluto's far side, sculpting it much like the patterns on its moon, Charon. Oliver White, a planetary cartographer at the SETI Institute, played the role of a cosmic detective mapping the geological intricacies of the far side. However, the limited image resolution left the mystery unresolved, awaiting future explorations. The discovery of fractures on Pluto's far side reinforced the idea of a hidden subsurface ocean, offering cosmic insights into the dwarf planet's origin. It suggested the ocean's formation during Pluto's early years, eventually thawing and causing surface ripples much like an apple thawing, as Pluto's cosmic story unfolded. In the Cosmic Theater's grand finale, the graceful waltz of Pluto's icy heart unfolded. As the frozen ocean expanded and congealed, the very skin of the dwarf planet displayed its chronicle through cosmic fractures. This enthralling narrative hinted at an age-old cosmic ballet where the transformation of ice orchestrated a symphony of surface fissures. If the cosmic chronicle rang true, the visage of Pluto's surface should have emerged as a wrinkled and cracked mosaic in recent photographic captures. Yet when the intrepid New Horizons probe cast its gaze, it revealed a celestial canvas adorned not with the anticipated wrinkles, but rather with intricate fissures. These cryptic marks etched upon the dwarf planet's countenance spoke of a narrative far more complex. It was a tale of a once liquid ocean now frozen, for the images captured were a cosmic quilt stitched together with the threads of partially solidified waters. The cosmic snapshots of Pluto's far side presented a mighty chasm, a rift that traversed the span of the planet's near side. A chasm so grand it encircled the entire dwarf planet, akin to Earth's East African rift dividing continents asunder. However, in stark contrast to our terrestrial counterpart, Pluto's rift was not a testament to migrating continents, but rather a cosmic scar etched by an ocean's inexorable freeze. The rift's sage whispered cosmic secrets, revealing that the liquid ocean had embraced the chill of the void almost instantaneously upon its exposure to the cosmic atmosphere. This chilling revelation held the promise of thriving marine life, hinted at by the crimson hue of the waters, a telltale sign of organic molecules at play. Samples drawn from the near side attested to the existence of this complex organic matter, bearing a rich reddish-brown palette, akin to the creation of cosmic art forged in the laboratory, a product of radiation akin to solar winds and cosmic rays. This revelation kindled the ember of possibility, suggesting that in a world like Pluto, life might not be a stranger. Ammonia, an essential cosmic alchemist, enabled the birth of molecules essential to life's orchestration, weaving the bases of RNA and DNA. While it did not insinuate the genesis of life upon Pluto, it sang the harmonious refrain that life, if delivered to this frigid realm, might persevere. The enigma of red ammonia-imbued ice on Pluto's near side stood as an astronomical beacon, shedding light upon the prospect of rich organic compounds, a notion that found resonance among the celestial scholars. It was not a proclamation of life's origins, but rather a cosmic echo whispering that life might find its home amidst the cosmic dance of Pluto. Beyond the quest for life, the far side's revelations birthed a symphony of riddles awaiting the inquisitive minds of cosmic explorers to orchestrate their solutions. Astronomers were greeted by an astonishing sight as the James Webb Telescope unveiled the secrets of the near side of Pluto. In these initial snapshots, ice behemoths, towering like skyscrapers, came into view, occasionally ascending to staggering heights of a mile, akin to 3 times the majestic Empire State Building that graces the New York City skyline. These colossal ridges, like serrated knives, emerged with a uniform distribution, thrusting themselves into the celestial canvas, where their majestic spans could reach an astonishing 19 miles. Navigating such an otherworldly terrain would indeed be a daunting odyssey. While these enigmatic formations tantalized the imagination, they remained enigmatic blips on the cosmic radar until the intrepid researchers revealed the mysteries concealed on the far side of Pluto. Although the current map may bear an aura of obscurity, the telltale signs of this bladed topography linger throughout the entire cosmic circumference, resurfacing on the western extremity of the near side. This enigmatic phenomenon encapsulates one of Pluto's cosmic conundrums, for it extends over a region on the far side that dwarfs its near side counterpart threefold. Upon the highlands and plateaus, spectral revelations shed light on the composition of these razor-sharp ridges, a tapestry woven from methane ice that forms a celestial girdle around Pluto's equator. Yet, the origin of these ethereal formations remains veiled in cosmic intrigue. Speculation flutters suggesting that akin to frost on Earth, the methane in Pluto's atmosphere congealed and descended to the planetary surface. The startling resemblance between these formidable ridges and their terrestrial counterparts in the high Andes beckons the cosmic sleuths to explore the second possibility with ardent curiosity. While Pluto's versions dwarf the penitents of South America in height, these striking cosmic formations shaped by the radiant cosmic spotlight cast their enigmatic spell under the sun's gaze. Flourishing near the equator, where solar radiation dances in its most intense cosmic ballet. Sublimation, the enchanting process believed to carve intricate troughs amid these razor-edged ridges, is an ethereal dance orchestrated by the cosmic conductor, which is sunlight. One thing remains unshakable: Comprehending the enigmatic ice fragments and Pluto's cosmic terrain, shrouded in mystery, beckons the intrepid cosmic explorers to plunge into the labyrinthine climate of this diminutive world. The Sarg of Pluto, a celestial voyager in the tapestry of the universe, mirrors humanity's ceaseless quest for enlightenment, painting a vivid portrait of the ever-evolving nature of our cosmic comprehension. In the ongoing cosmic odyssey, relentless researchers tirelessly toil to enhance the intricate climate models, seeking to mirror the observable celestial symphonies with utmost precision. Their daring quest extends to the boundaries of laboratories where they endeavor to recreate the ethereal essence of Pluto's atmosphere and perhaps unlock the secrets of a hidden ocean. The cosmic spotlight embodied by the James Webb Space Telescope is now poised to cast its celestial gaze with greater intensity upon this celestial enigma. While it may not deliver high-resolution portraits of Pluto, its unique wavelength perspective is a beacon of hope, igniting our fervent curiosity and offering the tantalizing possibility of unexpected cosmic revelations. And so a tantalizing riddle lingers as Pluto, the cosmic enigma, keeps us on the edge of our cosmic seats. The age-old question echoes anew. Are we truly alone in the vast expanse of the cosmos? As this celestial voyage draws to a close, we extend our gratitude for joining us in another enthralling episode of Spaceverse. While you linger in this cosmic realm, do not forget to embark on further mind-bending odysseys by selecting the video adorning your screen, delving into the awe-inspiring mysteries of space.